Awesome. Thanks a lot, Nina. Okay, so it looks like there's still a few of us trickling in, but in the interest of time, I'm going to go ahead and get started and go over the homework from this week. So you should be looking at my RStudio. Is that correct? Okay. And I'll make that full screen and zoom in, I think. There we go. Oh, that's pretty far. Can people read that okay? Okay, I'm seeing some thumbs up. Great. All right, so we will spend a couple of minutes going over homework here quick, and then dive right back into some new material for ggplot, and then we'll talk about color this week, and then wrap up the second half of class. Liza will talk about generating actual like publication quality plots. So for your homework, you were asked to summarize some information about this Gapminder data set, and then also do some plotting. So we can look at Gapminder really quick, and we can see that there's a column for country, one for year, and then population, and some other information like life expectancy and the GDP for the country. So the first thing we asked you to do was to summarize the mean life expectancy on each continent. So to do that, we would need to use this group by function to be looking specifically at continent. And then once we are working within our continent group, we can summarize and look at how would we do this? Mean of life expectancy. What will that give us? That'll give us a little table with one row for each continent, and then a column with mean life expectancy for that continent. Now, if we wanted to actually plot the change in this over time, were we hoping to do that at the country level or the continent level? I can't remember. Also the continent. So we could do something similar, but rather than grouping only by continent, we could also group by year, which I believe is in lowercase. Yep. And then summarize and say mean life is equal to the mean of life expectancy. And we can just look at that really quick, and we see that we now have a column for continent and year, and then the mean life expectancy for each of those rows. So we can pipe that directly to ggplot and aesthetically map year as our x-axis and life expectancy as our y-axis. Now, if I just ran this, I would be missing something, right? Because we brought our circus to town, but we haven't put anybody in the circus ring yet. So we need to add a geom point, which will add points for each of these observations. And let's take a look at that. Okay, now we have a bunch of dots, but it's kind of hard to see what's going on. So we can map also continent as our color and get a better idea of what is different across these continents over time. Does anybody have questions on problem 1? Okay. So then you were asked to copy a chunk of code that looks like what I have here on line 23 and draw some inferences about the plot. The first thing we asked you was, what's the function of this scale x log 10? Can someone tell us what they came up with for that? What is that scale x log 10 doing?
I can go, or if someone else wants to.
Sure. I was just gonna say it's changing the scale of the x-axis.
In what way?
By log transforming it.
Yeah, exactly. So we have added basically a log transformed x-axis here where each incremental step in space is multiplicative across the course of the axis. So thank you, Kirsten. You explained that as well as anybody could. I don't know what else to say about it. So the last thing we asked you to do was, oh, was there another question? Oh, the geom. So there's also a geom smooth here, and just to run through that quickly, this is adding a smooth linear version of a line to this plot and it's finding the line of best fit for that. So we can then do the same thing with our little challenge, but change the point size to correspond to country population. And if we wanted to do that, we could also stick size into one of these aesthetic mapping functions. And I'm going to do it here under point. And so we'll say size equals, and I can't remember, was it just called population? Pop. And then we'll have to remove the size from outside that aesthetic mapping because we're using population to determine the size rather than just sticking some predefined number in there for that. And so when we do that, we'll see that these really big countries, that looks like a couple of the Asian countries, probably China and India over a period of time, come out with really big dots, and some of the really smaller, like African and European countries, are very tiny dots.
I had
Okay.
a question.
Oh,
on that.
yeah, go ahead.
Before running it, I just assumed that the dots would be like absolutely massive. And so I was trying to divide population just because the initial size was like 0.25. And so I was trying to divide population by like 100,000 or 10,000 or whatever was appropriate. And it just did not like that at all. Is there a reason why I couldn't kind of like modify population in that way?
That is a great question. I would imagine, I would have thought that you could do it. So I'm going to try to stick it in here, and I'll say 10,000. Okay, so it looks like that still worked for me. Did
So it
you
just hates me. That's okay.
did you put it within the aesthetic argument, or did you have it outside of the AES?
Let's see. I ended up changing it so I could get on with everything. But I was doing it within AES, within Geom Point, and I've just run it. I get could not find function error.
And did you do like pop divided by 10,000 or whatever?
Yeah, I think 100,000 is what I was doing.
Huh. Very.
And as far as I can tell, everything looks identical. I guess I'm starting with a pipe. I have Gapminder piped into ggplot instead of, or I guess I also have it. I just have that in the addition at the beginning.
All right, maybe during the break we can take a. Oh,
Yeah.
go ahead, Rachel.
Oh, I was just wondering, are you might be missing a parenthesis or a plus sign somewhere, like somewhere else in it, just because that can mess you up and you think it's, oh, I can't do that, but really it's, oh, I messed up the syntax somewhere else.
Yeah, maybe at the break I'll ask somebody to look over my shoulder because I feel like I looked for parentheses, but it's always easy to miss something.
Okay, cool. Yeah, let's come back to that in maybe during the break or something. But in the interest of time, are there any other questions on the homework quick before I move on? Okay, super. So I believe the last thing that we did last week was essentially building these plots with a couple dots on them. So we have surveys complete is a data set that lives in data, and was it portal data joined? I can't remember which. Yes, it sounds like I'm getting some nods there. So we can do all sorts of things like pipe the surveys complete into a ggplot and look at things like hind foot length related to weight and add points. So some other things that we can do is add lines to things, and oftentimes lines can be useful for something like time series data. So let's take a look at, sorry, I didn't label these sections very well. Let's do time series first. So if we look at the head of our surveys complete data set, we have month, day, and year, and then a bunch of information about our plot and the animals that we caught. So if we count our different species that we see within each year, we could look at how those densities change over time. So let's create a data frame called yearly counts, and we will stick surveys complete into that, but we're going to modify it so that we're only looking at the number of each species that we see in each year. So we can do that with the count function, and we can take a look at that. And what do we see? We have a column for year, and we have a column for each species, and then n, which is the number of species that we saw each year. So observations by year. And so with that, we can now start to plot some time series. And we will do that in a similar way that we did our geom points, but rather than using a geom point, now we're going to use what's called the geom line function. So let's call ggplot and tell it that we want to use yearly counts for our data. And we want to map this aesthetically using, sorry, there's a fly in front of me that's very distracting. We want to use year on our x-axis because it's a time series and we typically put time as a independent variable. And then we'll use the density of each animal, so that would be n, as our y variable. And if we simply do it like this, we will, again, generate that plotting space, but I didn't add any sort of geom. So rather than point like we used before, we can use geom line to connect each observation through time.
Christian, it autofilled yearly counts instead of years.
Oh, thank you. Hey, look at that. All right. So we have graph now, but it doesn't look very nice, does it? The issue here is that for each individual year that we're looking at, there's lots of observations. Let's look again at this yearly counts. In just 1977, there's at least 10 unique species. And ggplot is trying to put all of these different values on a line within each year. So what we need to do is tell ggplot that we're actually going to group the data and we'll plot according to the group. So this made an ugly plot. Instead, we can use grouping to plot multiple groups. So we'll do something similar where you say ggplot data equals yearly counts. But in our aesthetic mapping, we'll still say x equals year and y equals n, but we'll specify that group is going to be equal to species underscore ID. And then similarly, we'll add this geom line. And now what we should get is all of these individual lines representing time series for each individual species. Does anybody have questions on adding lines and grouping by variable in your plotting? Okay, super. So this is much prettier to look at, but it's still a bunch of black lines that don't really mean anything, right? So we can use color to differentiate groups. And when you use the color argument, ggplot, at least in my experience, I don't know if this works 100% of the time, but typically if you use color within your aesthetic mapping, ggplot understands that you're grouping by that variable. So let's try data equals yearly counts and AES X equals year, Y equals N, and then rather than group, let's say color equals species ID. And once again, add our geom line and see what that looks like. All right, now we're working with something. Each of these lines are a different color that corresponds with the species ID. Unfortunately, there are a ton of species and it's really difficult to differentiate, for example, between, I think these Ds are different Dipodomys species, so some sort of like pack rat or something, I don't know. but they're all kind of the same color because R is struggling to find unique but highly differentiated colors. And so we're trying to kind of break apart too many groups at one time. And dealing with this color variability is a huge stepping stone to effective data visualization. And that's going to be a big focus of what we talk about today. But before we talk about getting through a ton of different colors at once, let's talk about one more way to break up data at the group level. And that is called faceting. I think facet is a word that I had heard of before ggplot, but I don't know why I knew that word, and I don't know that I actually had a good mental definition for it. But in using ggplot specifically when I'm graphing, faceting makes a ton of sense in the sense that what we're doing is wrapping data. We're wrapping data across plots by group. So for example, let's look at our yearly counts again, but rather than having the color be mapped, having species ID mapped to color, we will wrap our plots around species ID, and that will make sense once we actually do it. It's kind of hard to put to words what exactly is going to happen, but I think you're going to see very shortly why this is an effective way of breaking apart data. So once again, we're still interested in all the same variables, but we're not going to add a color argument this time. Instead, we'll add a geom line like we normally would, but we're going to add one more line to define this plot, and that is the facet underscore wrap. And when you are indicating that you want to wrap something across plots, we use the tilde to say we're going to wrap by this variable. So we'll say tilde and then species ID. And this time I'm going to make this bigger now because we're going to need a lot of plotting space for it. Oh, geez. We got a lot of warnings. Okay, great. So what we can see here is we've generated a plot for each species that exists in the data set. And there are a ton of messages that came out from the ggplot function. And it's saying, geom path, each group consists of only one observation. Do you need to adjust the group aesthetic? And if you look at these plots, you'll see lots of empty plotting sort of panels. And that's because a species might have only been observed in 1 year. And you can't add a line when there's only one point to be connected. So we have a lot of what look to be blank plots, but if we did the same thing and used geom point, I bet that in all of the plots there would be at least 1 point. Okay, I'm really glad to see that because I wasn't 100% sure that was the case, but it seems like my hunch is justified. So yeah, there are lots of ways to break up data into groups and to effectively visualize lots of different variables at one time. And we have a challenge for you that I just put up on the website today. I'm really excited about it. I'm not 100% sure it'll work because I've only tested it on my computer, and I think Christine tested it too. But in the interest of a fun challenge, I'm gonna paste it into the chat right now. The premise of this challenge is that you have a new collaborator and they sent you a data set with very little information about it. Your job is to ask an intelligent question to this collaborator, but to do that, you need to look at your data. So you can access it using this mystery assignment arrow read underscore CSV, and that should bring it into R for you. So I'll stick that in the challenge as well. And there are 3 columns in this data set. There are X, Y, and group. And your job is to figure out what's going on with this data set before you come back to your collaborator. So I would recommend trying out the facet wrap function and then play around with your point size and maybe some transparency settings and see if you can find any signature in this data that you might find interesting. We're going to give you 5 minutes to work alone, and then we'll stick you into some breakout rooms for 5 minutes as well, so you can talk a little bit about it. And then we will reconvene and see what we came up with.
I like.
Thank you. It was, I gotta give credit to Christine because she's the one who found the challenge in the first place. We just added some new data to it and wrote it up for the website. So I take it that at least one group has discovered our hidden signature in the data. Does someone want to walk us through what they did?
Sure, I can.
Okay.
So we followed your suggestion to change the transparency and the size. And so I have ggplot data equals mystery, aesthetic x equals x, y equals y. And then for geom point below that, I have alpha equals 0.1 and size equals 0.01. And then facet wrap tilde group.
Nice. And what did we get from that?
Pictures.
Some friendly creatures. I hope. Did this not right? Why isn't it? Oh, there we go.
I'm putting in the chat. I've made these before. I'm putting in the chat a little example of how to make a scatter plot like this from an image. It's
Oh, nice.
It's a fun thing to throw into your into a talk. People go, ooh.
I gotta move my Zoom screen so I can look at this. Awesome. Thanks for sharing that, Michael. Yeah, and so I actually forgot to include the second half of, I mean, not really challenge, but there's another thing that you can add to plots like this where space is important. And so we use what's called the chord set of functions, so we can define the coordinate space. And if we set chord equal, that means that for every unit you move on the x-axis, you'll move the same amount of space in a unit on the y-axis. And so this will restore the normal proportions of these animals, so you don't have like a really long fish. That'll become super important for people that are using ggplot for spatial work. Okay, so the last thing that I want to talk about, before I move on, were there any questions on the challenge that we did? Okay, super. The last thing I want to talk about before we move on to color is ggplot's themes. Now, there are lots of so-called themes in ggplot, and these define sort of how the plot actually looks. And so if you've ever made a graph in Excel, you know those graphs look very different from the types of graphs you see in publications. And graphs that you make in the base ggplot, like what we're looking at here, probably look very different from graphs that your advisors make if they use like SPSS or some weird statistical thing. So the themes allow us to change all sorts of different things. So we're going to go back to this yearly counts data set, and let's check out what some of these themes can do. We'll do, once again, X is year and Y is N for our yearly counts data. And we can add a geom line like we did before. And we'll say the color is, once again, species ID, so we can actually figure out what we're looking at. You know what, I'm just going to use group so that we don't eat up all the plotting space with the legend. So all these lines will be black, but what am I missing here?
We don't have anything named data.
Oh, no, we don't. What's it called? Yearly counts. Thank you. Okay. So we have a bunch of lines, and it's understood within our little community right here that each of these lines represents a different species. what we can do is add themes onto our plots. And themes are defined by theme underscore and then something. And there's a bunch of built-in themes. So we can use the BW, which is black and white, to generate a somewhat different looking plot from what we had before. Now you can see there's a sort of accentuated exterior rectangle for this plot, and the gray interior has gone away. We have some nice little gray cross hatches to look at, et cetera, et cetera, et cetera. We could also use the same thing, but say theme classic. And this will give us something that starts to look more like the hyper simple plots that are, in my opinion, a little bit more effective for communication and what a lot of people expect to see in journals. So the classic theme is one of my favorites, and I have a slightly modified version of the classic theme that I built and saved. So when I make plots, I can automatically just call that and it remembers everything that I'm interested in. You can also adjust individual elements of your themes. So adjust, let's say fine tune. And for example, we could take this same data set, but rather than using one of these built-in theme functions, we can simply say theme and then parentheses, and you'll see a bunch of stuff pops up into our little yellow rectangle of help. And so there's line, rect, text, title, axis title, et cetera, et cetera, et cetera. And each of these is an element of our graph that we can edit. So let's say we want to have really big axis labels. We can say axis.text, and we could select just the x-axis or just the y-axis, but I'm interested in doing it with both of our axes. And we're going to say that this is everything is referred to in terms of elements in ggplot. So this is an element text. And then we can say size equals, we'll say 42 because it's the answer to everything. Now we have massive axis labels and they look outrageous, and we have very tiny axis titles. So obviously 42 wasn't the best approach here. Let's say 12, and then we can say axis title, and let's just do it with our x-axis, is going to be an element text, and we'll say size equals 14 to make it a little bit bigger than our axis labels. Now we have a slightly enlarged axis title just on the x-axis, and you can see it's somewhat bigger than the y-axis, and our axis text, that is the actual labels for the tick marks, is only slightly enlarged. Okay, so I'd like to move on to color now, but before I do that, does anybody have any questions, lingering questions on plotting, faceting, themes, things like that? All right, great. So I need to change some windows here because much of the color discussion needs to be on not my monitor because it doesn't cooperate with some things I want to do. So let me, if I just start a new share, is it going to like double share, or is it just going to change my share? Are you seeing my desktop with data visualization open? Okay, super. So let's move on to visualization best practices here. If somebody could throw that in the chat, that'd be helpful. There is a long history of visualizing data, and enough people have spent enough time on it that there are some pretty well-established guidelines for things that you should and should not do. This is a map from, I don't even know when it was made. It's a super old map of Napoleon's march to Moscow and subsequent retreat. And the guy who made this managed to fit 6 different axes of data all into one plot. And I have to say, it's pretty visually stimulating as well. That being said, it's in a language I don't speak. And so one thing to consider when you're making plot legends is people who can and can't speak your language, because we live in a very English-centric society, but a world that does not only speak English. There's also a history of visualizing data spatially. So here's a plot, I think it's cholera outbreaks in relation to water sources. But what I really want to move on to is how to best make a graph for you. So you might have seen this little moving GIF of calories versus type of food. And it started off really busy. There were a ton of unnecessary colors. There was like this weird brown paper bag textured background and like lots of things that are at the end of the day fluff and are maybe fun for a third grader to put in their PowerPoint with word art, but not great for like academics. And so what we really want to promote here is that less is more. This is not great. We start to approach something that looks really nice. Let's see, what did I want? Okay, so color is the big thing that I want to hit on here before our break. Color is kind of everything when it comes to plotting, because you are going to be communicating with a broad audience, and some people struggle with differentiating color because they have color, what's the word? We'll say colorblind. I think there's a better way to say that.
Yeah.
But color impaired. And so, for example, here we're looking at two circles, and I'm not sure how many of us are in the class, but at the end of the day, color blindness is actually fairly common across especially men. And odds are, if you're giving a talk, if you're writing a paper, somebody looking at that material is colorblind. And it's pretty important to consider that when you are making your data visualizations. So there are a few links that I want to pass along to you because I think they're pretty relevant for how we think about color. And I'm struggling to get my windows in order here. Apologies. Okay, the first one is a Nature paper that just came out. It was either last week or the week before. So I'm going to post that into the chat right now. And it is about the use and misuse of color in science. And I think they do a very good job of laying out how color is often used and what's wrong with that. So one color ramp that you frequently see as a default, especially in, for some reason, R-based plotting, and especially frequently in like raster spatial data, is this, I think it's called the rainbow color ramp. And if you take an original image, so this black and white picture of the Earth and Marie Curie and an apple, and you map that to this rainbow color ramp, you lose a lot of the information in the image just because of how your eyes work. And this is like not a scientifically defined color map. But if you take something else like this so-called Batlow color ramp and apply that sort of color filter to the same image, it becomes meaningful. And so we can sort of look at how, we should think about what we're communicating when we're communicating data. And so here we're getting into some of the color deficiency issues where you can look at, let's say, this jet color ramp. So that's the rainbow one that we showed above. And you can see how someone who has a different type of color deficiency as these middle three columns, there are several places where you actually can't differentiate different values. So if you look kind of like right in the middle, and then just to the right of this yellow, those are pretty undifferentiable to someone who has deuteranopia. And a really good way to think about how effective your color communication is to say, will it work in grayscale? And if you can efficiently show differences in values in a grayscale view, it will guaranteed work for anyone with color deficiencies. And one way that I like to check whether my data are being colored in a way that is colorblind friendly is to use this software called Color Oracle. And I can post that in the chat as well. Let's see, chat. I can't find my chat screen. It's colororacle.org. And it's a free software. It works for, I use it on Mac, but apparently it works on Windows and Linux as well. And it lives, I don't know if you can see my top bar up here with like my Chrome and file edit history stuff. I don't see any thumbs up. There, everybody has like a little, oh, okay, sweet. There's this little circle with colors in it that looks just like a colorblind test circle. And this software lets you preview on your screen what someone with these different deficiencies would see. So let's go back to this original plots of Marie Curie. And we can look using these different filters, how someone with color blindness would see these different sort of color ramps. And you can see across the board, no matter which color deficiency we're talking about, you can always make out what is needed to be emphasized in this Batlow color ramp. Does anybody have any questions about that? Because color blindness is a tricky thing, but it is important to think about, especially because even if someone isn't colorblind, if they're printing out a paper that you write, they're probably printing it in grayscale because nobody has money for color ink, let's be real. Let's see, I think I had one more thing I wanted to talk about here. Oh, that's right, okay. So when you're using color in ggplot, there are so-called color scales or color ramps, and kind of like we had geom_point and theme_black white and things like that, we can define our color scales using the scale_XYZ argument. And if there are colorblind friendly scales that are built into ggplot, but there are a ton of additional color scales that you can get. So a really popular one is the Wes Anderson color ramp, and I think Nick talked about this maybe last week or the week before. But if you like Wes Anderson movies, you can check out this package that you basically install the package, and it comes with a bunch of pre-built color palettes for your ggplot stuff. And depending on your favorite Wes Anderson movie, you can choose a relevant palette from those movies. So here's the Royal Tenenbaums. They have 2 different color ramps for that. But I do have to warn you, if we look through our colorblind lens, sometimes these are not super colorblind friendly colors. So take caution when you're applying fun color. I do have to say, I really like the Wes Anderson package as well. You just have to be careful about when and how you use it. The other super useful one is Viridis. I'm not sure where the name Viridis comes from, but it is super effective at differentiating tiny differences in our data values. So here's a weird plot, and the color ramp, you can see, even if you're using some sort of color, any sort of color deficiency or grayscale, you can see the differences across the board, and within our actual data set, you can see a lot of really fine scale differences across the values that are being plotted. Also on the website, we have a series of visualization do's and don'ts. You can go through them at your leisure. I'm not just going to read a checklist off to you, but there's lots of things to keep in mind as you're generating your plots. So yeah, check out the visualization tips, play around with your scale_colors. Anytime that you map a variable to color, you can adjust it with that scale_color XYZ. And with that, I think this is a pretty good place to take a break before Liza talks about CalPlot. So we'll give you 10 minutes, come back at 3:09, and we can get started from there.
Yeah. Yeah, I don't know. There's like stuff on the ggplot website about it as well, but it's pretty slick.
Cool. Well, maybe so hey everyone, welcome back. We were just chatting over the break about color, things we're excited about, and Michael brought up sort of a new ggplot color features. And for once, maybe in all the weeks, we have time this second half where we're not going to be rushing through materials. So I think what I'm going to do is I'm going to pick up where Christian left off and going to go over just some of the packages or some functions for kind of merging together different plots kind of for publication outputs. And then we should have some time to go over what Michael was talking about, which is just kind of another cool new color feature of binning continuous variables by color. And we can also just kind of open the floor on plotting questions because, you know, as you can sort of tell, we're like skimming the surface on ggplot. Then the number of GG extensions, I mean, let alone the color palettes you can create, the series of arguments in all these different levels of sort of this ggplot house that we're building are infinite. And so there are a lot of questions that might come up and maybe you've run into some on your own. So we'll kind of wrap up the planned material and then maybe open the floor for cool things we want to share about plotting. But before that, does anyone have any questions about anything Christian touched on, color-wise, faceting-wise, grouping? All right. And I'm going to get my screen situated for a second. And let's see. Okay, I will start screen sharing in a sec. All right, and should be our screen, thumbs up. Let's see, I'm just gonna run. I guess we've been working with Gapminder so far, and all right, updating. Got my tidyverse loaded, and all right, so where Christian left us off, we were looking at the website, and like you said, you can check that out for kind of a short list of do's and don'ts for plotting, which was put together by this group in sort of historical conversations around recommendations, but of course there will be things that a journal wants, things that your advisor wants, or your collaborators want. So the exercise, I think, in thinking about, you know, what do I plot? How do I plot it? Is often to think about, you know, what's the end result? What are you trying to communicate? Are you exploring the data for yourself, or are you ready to like tell your story in, you know, 1 to 3 plots ready for publication? But so I would say it's easy to get lost like formatting a plot and playing around with ggplot just for yourself. Like, you know, I just want to look at these 2 variables, and then 3 hours later, you're somehow like neck deep in color palettes, which is cool if you have the time, but it's nice to kind of back up and take that reminder and say like, oh, this is just a plot for me that, you know, I'm really glad that the colors are accessible, but, you know, maybe like prioritize when to really be diving into like the deep ggplot world. But so like I said, when you're finally ready, you're like, all right, this is the plot, or these few plots tell my story. These are what I want to put into a publication. How do we get you there? And so what we are going to introduce, I'm also gonna, did that zoom for everyone? Yeah, okay. So we are going to do Calplot and others for publication / communication. This is sort of the last thing we're jumping off on. And so we're going to be first installing or loading a few packages if we haven't. So I've said this now a few times. Calplot is a weird name. I found the origin because I was really trying to see how it would relate to like livestock or what like quippy R thing it is, but it's actually just the initials of someone whose initials were COW, where they developed this package for their lab, and now it's been more widely distributed. But if you have never used this before, we'll go to our install packages function. And remember, when we're installing packages in quotations, we will want to say calplot and run this. Because I've already done it, it looks like it's re-downloading. Great. And usually when I install something, I'll usually like $sign it out or just delete it, because in theory, you don't have to do that again. We'll do library, cowplot, load it in. As a reminder, do this at the start of every R session. You'll eventually have a long list of libraries that you'll be drawing in every time. All right, and so what we're going to do is we're going to make a few plots that say are our final publication style plots that we want to weave together. And to make these plots, we haven't quite done this yet. We're going to load in sort of these data sets that are already embedded within R. So if you're ever like looking up, if you're ever troubleshooting something for ggplot or really anything, you'll often come across these data sets that people use all the time, right? Like there's this data set about irises, there are some about cars, some about diamonds, and you wonder, how does everyone have this data, or why is everyone studying the same thing? And it's actually because there are sort of these built-in data packages. So usually they're called iris. What are the other ones? MT cars, diamonds, and MPG, etc. So in order to do this, you don't need to call these in. They are automatically in R as a data set. And so you can go ahead and just plot with these to start, but you might want to know, what are these built-in data sets? So let's start with diamonds. It automatically populated for me without having to do anything. And so diamonds, most of these are also pretty simple data sets. They don't have NAs, they only have a few columns. They have a few continuous and a few categorical variables, which just make them really great for practicing different approaches to data wrangling and plotting. So we have things like caret, cut, color, depth, table. I couldn't tell you what X, Y, and Z are, but that's kind of not the point. It's just that they're continuous variables. So we can make sort of a pretend plot with these, or something that we might want to know about diamonds. So this is just practice in our ggplot and piping syntax. We can start with the diamonds data frame, and we can start our ggplot. We already know our data. We use our aesthetic with X equals, and let's say clarity. So these is a categorical variable that we want on the x-axis. And because we're trying to plot an X categorical, and maybe let's just say we want to count up how many are in each of these clarity categories, we'll do a geom bar. And I will say, one of the things that I struggled with most of, like, okay, we have these data, and most often the examples you'll see are like continuous variables, but when you start working with categorical or something like bar plots, how do I know? You'll notice that sometimes you don't always need an X and a Y argument. And with bar plots or geom bar, you don't always need a Y argument. You sometimes can have one. Geom bar, you don't need a Y argument. But instead, you can often use a fill argument, which is similar to color in that it will color in by category something you want to identify. So in this case, we can do fill by cut, which is another categorical variable. And those are going to be our aesthetics that match up to a geom bar. So we can specify that and empty because we've already clarified what we want our aesthetics to be. And we'll go ahead and look at this first, and we can talk a little bit about some add-ons that we might want to do in relation to what we've just learned. So, all right, we'll see what defaults here. We kind of have a gray background. We get our labels at the bottom. We have cut labeled for all of our different colors. And all right, I mean, this is pretty decent. I'm trying to think of, what did we just learn that we might want to add to it? Christian talked about themes. So oftentimes I'll throw in a theme. I really like classic. And as I guess I sort of jumped to that really quick, but there are a long list of themes, and you can kind of play around with them. Some of them are intuitive, some of them are really similar. And if you hold over, you can actually see what some of the general specifications are within each theme, which might not mean a whole lot to you over time, but if you wanted to dive into, what themes you like or what bits of it you like, you could start poking around in here. But so I usually like theme classic, and we'll see what happens are that we lose our gray grid lines. And something else that is common to do, it actually isn't necessary on this, but I'll show it just for the sake of talking about all these different kinds of additions we can make to our plots, are that sometimes it can be really hard to read labels on an x-axis, and so we'll want to rotate them. And this will bring us back to the theme function that Christian pointed out. And I find the arguments with inside theme hard to remember. They're often ones that I sort of Google and will copy paste from the endless number of ggplot sites that you can reference. But we at least get a lot of prompts if we start with axis within theme. Let's say we want to rotate our x-axis text. And so this would bring us to axis text. And specifically, I want to be focusing on the x-axis text equals, and as Christian said, these element arguments are often how we're going to specify different details about the text. So element text. And then within that, I think this is where Christian had previously like changed the font size, changed the, maybe even the font type. So there's a very long list. Like they say, you can have family, face, color, size, and then adjustments and angles, which is what we're gonna just sample right here. So element text, I want my x-axis text to be at an angle of say 65 degrees. And I'm also want, what this will do is it will just switch it to 65 degrees, but it won't necessarily move it down so that it doesn't run into the x-axis. So sometimes you can play with V-just, which is vertical adjustment, I think, vertical justification. And I usually just play around with these and work out different numbers, somewhere between 0 and 1 or 1.5. They're usually based on like where a coordinate begins in relation to the text, but so we'll just show you what 0.5 looks like. And what's happened is that we have these turned to 65 and they've moved down a little bit. If I didn't include this V-just, then you can see that they just switched and they didn't get pulled down. So I'll make a few notes here. V-just 5. All right, so we're getting what's closer. You know, you could spend a long time on that saying, oh, I want to relabel my x-axis and my y-axis and my legend title, and I want to give it a title. And that will all come. Like I think ggplot is also one of the most Googleable types of things. Like it's at least, there are words that are intuitive to us, largely for as knowing what a plot should look like. It's not so much a guessing game as to like what's even possible or what function might it be. So I find that those sorts of troubleshooting are pretty easy. But does anyone have any questions on this process specifically or any of the details that I mentioned? All right, cool. So the whole point of this is that we're making some random plots so that we can eventually put them all together. So we're going to make a couple of these. So let's say we're going to name this object as our diamond plot or plot diamond. And we're going to make sure to rerun that to assign it. So now we have this plot that's been remembered, this plot that's right here. And then we can make a few more of these plots with other built-in data sets from R.
Liza, can I interrupt you a second?
So yeah.
One thing that we haven't talked about, I don't think, is that you can make a plot object. And every time you call it, you are plotting.
Okay. You mean like I just did, or to layer?
Yeah. Yeah. So like, and you can add stuff to it as well. But if you want to do more than just put a plot in your plotting window, like if you want to save it or use it down the line somewhere, you can assign entire ggplot calls to an object that you can then use later.
Yeah. So if this is something we haven't actually mentioned before, the same logic that has applied to how we've made new data frames, how we've named different objects, is that you can assign a plot to an object. So I assigned this plot to plot diamond so that I could call it a little bit later when I want to put a few plots together. And you'll see that this populates when I start trying to call upon it. If I execute it again, it remakes this graph for me. And the beauty of the ggplot sort of layering language is that you can add additional arguments even to that saved object. So let's say I did want to add labels, and there are a few different ways to add labels. For me, the easiest one is just to say labs, short for labels. And let's say I want to rename the x-axis and I just want to capitalize clarity, right? This will actually update this x-axis on top of this pre-saved plot object. So that's just a good thing to remember. All right, but a different data set we could make a sample plot with is MT cars, and we can check this out. Like I said, usually pretty simple data sets, and this one's pretty short. This. Does anyone have any ideas? I just want to let's make a quick geom point. So a scatter plot, you want to pick me 2 variables for what we want to plot, and maybe what do we want it to look like? What do we want to color it with?
I actually had a question. What is the head function and why are you using it?
Yeah, good question. I use that. So we've introduced a whole bunch of different ways to like look at your data at a glance. I think Christian says he prefers the structure call because it will tell you more about the data, that it's numeric. Mostly it will tell you what kind of data type it is, and it will list, I think, a longer list and tell you that this is a data frame. What head does is this is a short data frame, so it's hard to tell, but I think it usually takes the first 6 first 6 rows of a data frame and kind of gives you a mini glance at it, which is just like structure is a way of just saying, what does my data look like real quick? Or what does the head of my data look like? And you can also use tail, which in the case of MT cars will probably look exactly the same because it has very few rows. Actually, no, it has more rows than that. It just doesn't tell me how many rows it has. It will give me the last 6 rows of the data frame. So head calls the top 6 rows. Structure tells you structure, so ways of inspecting data. And it calls last 6 rows. But in either case, every time it will give you more or less your column names with a little bit of a glance at what that data looks like. So we have MT cars. Anyone have 2 favorite continuous variables in this data frame, or words that they just want to stare at and yell at me?
I used WT for the X and then MPG for the Y.
And what was the Y? Sorry.
Oh,
Wait.
WT was the X and then MPG was the Y.
MPG. All right. Any colors? Any specific?
Red, because that's the fastest color.
Just red. Let's see. Well, let's look at what this looks like right now. So we have a scatter plot. Do we want to color by anything, or do we just want to make it red? This could be it. All right, we're losing some information here in our ink to data ratio, but this is your decision as scientists. But let's say I want some uniformity. I want to also use this. Oh, wait. Yeah, I want to use this theme classic because I want all of my plots to look similar. How do we feel about this? Good. All right, and then let's make a third plot because we're going to finally weave these all together, and we can use the iris data frame data set. So just to give you a glance of this. We have some more continuous variables. So we'll take iris. no one really seems to want to give me plotting ideas, so I will do it myself. And we'll make another scatter plot where let's say X is going to be the sepal length. We'll make Y is the sepal width. And let's in this case say we're going to color by species. And then we're going to want another GM point because we're working with two continuous variables, and that's one way to look at that. We're going to keep up with our theme classic. And let's see what this looks like before we maybe talk about color. Let's see.
I think you missed putting in the AES.
Yeah, that's the issue. All right, I forgot to call on aesthetics. I just jumped right into my coordinates. Aha, okay. So you'll notice, this is at least a point of conversation. You'll notice that when I plotted the first plot, it sort of automatically plotted these sort of more like Veritas color looking type colors that Christian had showed us before. But this plot's sort of these default 3 colors, but this is not, I don't have the ability to flip through colors on my computer, but let's just say these might not be the friendliest to view. So if I wanted to add a color, then just like Christian taught us, most of these arguments start with a scale underscore color, and then there'll be a long list of different color options. And even without installing or downloading the Veritas package, Veritas is actually now built into ggplot. And you'll see that there's Veritas and then there's an underscore C and D, which are really just trying to say, is this variable that you want to color continuous or discrete? Because I think it would bin them differently in a sense, or create kind of different categories. This is hard to explain. It wouldn't make it look so much of a fade as it would like really distinct colors. So in this case, species is distinct. So we want our scale colors to be thought of as discrete. And so now we get these colors that are presumably more friendly to all viewers.
And you'll actually get, you might get errors. You'll get something like continuous value passed to discrete scale. That happens pretty frequently. That happens when there's a mismatch between you passing like a numeric column and you're saying plot it with discrete values, and it says, I don't know how to do that. So that's a pretty common error that comes up, and it can happen in all sorts of ways. Like if you try to say your x-axis, it can happen in ways. So just be careful when you're making those distinctions.
Yeah, yeah. And so I just switched it to see, would it accept C as an argument? And it told me almost verbatim the exact error that Michael mentioned, which is discrete values supplied to continuous scale. It recognizes that species is a character, and in that way is almost is inherently discrete, at least to R. And so it didn't want to match a character data type to, in theory, a continuous color scale. So I'm going to use D for discrete, C for continuous. And so we have what we just saw. And I've been doing a pretty poor job at annotating and at assigning plot names. So I'm going to back up a little bit because I created plot diamond, but I also want to create plot cars because naming these objects is how we're going to put them all together. And I want to assign plot iris so that now we have 3 plots that in theory, if these for some reason, information about diamonds, cars, and irises were what I wanted to put sort of in one cohesive set of plots, how would I do this? And we want to put all of these together with cowplot. And particularly it is the plot underscore grid function that is one way of lining these all up. Put these together in a grid. So the most basic understanding of how to put these into a grid is a pretty simple syntax in that you are just going to list first all of the plots that you want to put together. So I want to put my plot cars, my plot diamond, and my plot iris. So I want all of these to somehow be put together. I want to call them different things. So there'll be a labels argument, which is label equals our concatenate function. And let's say I just want to call these A, B, and C, because that's a common practice in journals. And you can then specify, let's see, if we don't do anything, what will happen? Let's say plot grid. And it automatically, a little tough to see here, but it automatically just puts them in an exact grid. So it doesn't really adjust for the fact that we have a blank space in our bottom corner, but you see it labels them A, B, and C and keeps all of what we had previously. This is cool and is really helpful, but sometimes you might want to say, I don't really want this gaping space. I want, actually to elongate one of my graphs. And so not exact grid arrangement, we can use ggdraw and drawplot. So also within the CalPlot package, there are two more functions that sort of let you do a little more complex drawing or sort of mapping of your plots into a space. So when I kind of think about this as like meta plotting, because this is, you're now going to give specifics on how do you want to plot your plots within a particular space. And ggdraw kind of functions is similar to ggplot in that it sort of creates this like blank space of saying, okay, I want to create a blank space where I'm going to put my plots on. And if I execute just ggdraw, it just creates a blank space, which is actually exactly what ggplot does when you just use ggplot on its own. But so creates a blank space. But like with ggplot, if I add a second argument onto this, which is drawplot, onto ggdraw, then I can start saying what coordinates do I want these plots to be in this blank space. It's helpful first maybe to read a little bit about drawplot because it can be hard to start thinking about your space as far as coordinates, but it's really specific in that it says to draw a subplot, by default, coordinates run from 0 to 1, and the point 0, 0 is the lower left corner of the canvas. So you can position your plots in relation to this idea that this blank space has two axes that are both 0 to 1. So what might this look like? Let's move this up here. So in each of these draw plot functions, we're going to name the plot that we want to specify the coordinates of. So I want to take my plot iris and I want to tell it where it's going to be. So let's say I want iris to be the bottommost plot and I want it to take up the whole length instead of splitting up and leaving that blank space. So plot iris would be x equals 0 because I want it to start at sort of the bottom left, at the left side, and y would also equal 0 because I want it to start at the bottom left. Its width would equal 1 because that is the maximum width of our space, but its height would only be 0.5 because that means it's going to take up half of the height of our space. You can then add on to this and keep doing draw plot functions with each of these plots, and again specify where each of them will be in this two-dimensional space. So let's say I want cars to be on the upper left-hand corner. So x is going to equal 0 because that is our left. Y, however, will equal 0.5 because that is our upper quadrant of this space. And instead of taking up the whole width, I want it to split the width with the third plot that we haven't plotted yet. And I want height also to equal 0.5 because now we're taking up fractions of the space. So actually, if I stop here and just execute this, we'll see, what we've done so far is we've set our iris plot to take up 0 to 1, but only 0 to 0.5 of this space. We've asked our cars plot to take up half of the X and half of the Y axis. And so by adding one more of these draw plots and positioning our last plot, which is our plot diamonds, does anyone want to say what the X axis would be, or what the X coordinate would be, or really what any of the coordinates would be? 0.5, I think Jillian said. Y is
Also 0.5.
width and height.
0.5 for both of those.
Yeah. All right, cool. So this is us sort of trying to fill in this last space in theory, and that's what it did. This is really helpful because often, at least I've somehow never managed to have evenly numbered plots that will perfectly fill a grid space. And sometimes there's data that you want to take up more or less space depending on sort of the goal of your visualization. Does anyone have any questions about this?
Can you do more than just one quadrant? Like the last plot you just did is like kind of shrunk. If you wanted that larger, could you change the numbers so that it goes a little bit into the left top quadrant?
Yeah, let's see. So if we change our X, say, to 0.3, where I don't want it to start here, I want it to start over here, I think we'll actually see some overlapping. And I don't think it will be really upset with us for doing that. Ooh, but it actually covers it up. It doesn't like, there's no transparency there. So it starts butting into our our 0 and a width of 0.5 of our other plot. So you can totally move them around and make them overlapping and make them different sizes. If you felt like this one was squished, you could adjust all the sizes. Now this requires then a lot of like typing and retyping of coordinates. There are, I would say, not a ton of great examples of like ways of arranging. Like I think grid arrange is also a pretty clunky version of like typing out coordinates. But I think last year, what was shown? Oh yeah, patchwork is a slightly, I see Michael nodding, and I'm saying this because I have seen him present on this, but I'll pull this up in our adjusting screen. So patchwork is another package that I'm not going to show in R, but you can kind of see a quick example based on this GitHub repository, and I'll paste this link in the live code, is that you can assign your plot names, and then instead of using all this coordinate thing that we just did, you can really just add them together. So let's say I want plot 1 and plot 2, and they'll just end up next to each other. You can use kind of additional syntax. So this would take sort of reading a little bit about this package, reading about these functions, and understanding what specifics they need to help with this. But let's say I want plots 1, 2, and 3 to divide across the top, divided by P4, which will take up the entire length of the bottom. I've never personally played with this, so I don't know how easy it is if you wanted to say, I want plot 1 to actually take up 2/3, and then plots 2 and 3 to take up 1/6. And there's probably not a perfect solution, but know that sort of these quicker, easier ways are out there if you don't have too many complex coordinates for where your plots are going to be. Patchwork is in here. All right, and then I want to show just one more interactive way of using plots, and then we can kind of have the last 5 or 10 minutes just to chat and ask questions. Although before I do that, I think one question I had when I first started R is like, okay, like how do I get these plots out of R? Which this is a point, and I mean, there are actually a variety of ways that you could go about this, but I usually use a point and click method here, which I'm welcome to feedback on, but I'll usually navigate just to the export button, and you'll see some pretty intuitive options, which are to save as an image, which I think is usually a PNG file, to save as a PDF. I think these are intuitive ideas for us. And you can also copy to a clipboard. So it will copy the image, and you could then paste that into a Word document or into a PowerPoint or whatever it might be. So they're pretty easy to get out of R, at least as plots. And so then what we're about to do will then make that a little bit harder. But anyone have any questions, thoughts?
I don't know if you're going to mention this, but the one alternative is the GG save function, and then you just provide the file path of where you want your image to go, and then I think what file format you want, like JPEG or PNG. I can't remember all the arguments, but that's another option.
Yeah. So you can usually, if you save your plot object, you could do GG save. I actually don't know what the exact syntax is. File name, and then you would usually specify a path. So like when we write out file paths as to where something might be, you could specify where you want this image to land, what kind of file you want it to be, what sort of size you want it to be, all of these specifications that if you want to save it somewhere in a particular fashion that the automatic export doesn't give you, GG save is a good way of doing that. Cool. So let's talk about Plotly, which is just a fun package for interactive plots. And it also makes making interactive plots, I think, a lot easier. Like when you see someone do it, you're like, wow, you're super impressive. And then you're like, oh, I can do that too. There's just a function or a package for it, which is the case with almost everything I find. It's just knowing what they're called and where to find them. So same with CalPlot. This would be, if you've never installed or used Plotly, you can install packages Plotly and execute that. And call Plotly into your library. All right, and it's pretty simple. So if you remember, let's say we have our plot. Let's look at plot iris. So because we've saved it as an object, this has maintained its original form, even though I've then tried to put it into different arrangements. And if I wanted to make it interactive, it's really as simple as using the, let's see, ggplotly function, which ggplotly, you can see it's calling now upon the Plotly package. And I will just put the name of my plot in there. And let's hope this works. Real quick, I will announce to some people, and I was running into this warning even as early as this morning, which depending on if you are a Mac user and you have somewhat recently updated or gotten a new Mac, I was running into errors recently about a Cairo package that was missing. And I did what I do with all my R problems, and just if there's a warning I don't understand, I just paste the warning into Google and hope that someone on Stack Overflow or elsewhere will have found it before. And this comes down to like a Quartz installation thing, but you could follow that link if you have that issue. Otherwise, it should be really easy to have generated a plot that looks pretty similar to what we saw before, but you'll see that kind of like the default, well, actually you'll notice that we're no longer in the plots tab. We are actually in the viewer tab, which is where sort of interactive generations, like, yeah, more, I would say more interactive products that you can create in R will end up. And some of the defaults have changed as far as font and things, but you'll notice there's also this whole suite of objects up here. But maybe the most important bit is that now when we hover over our points, we will have information presented to us about them, which is the exact coordinates of the point that we're selecting and the species. This is a really fancy, cool thing and is really helpful both for exploring your data. So if you're just, first glancing at this and you want to throw any plot you've made into Plotly, then you can be able to, you're able to explore your data a little more closely. Or if you want to, if this is an end product and you want to make this data sort of navigable for others and you want people to be able to really dive in, you can make some arguments. I think there are a lot of features. This is admittedly something I don't play with that often, but you can say change, I forget what they, what they're called. I think it's dynamic ticks. Wait. Yeah, so is this the tooltip? Yeah, so X, Y, and color. So you can change your tooltip to change details that are given and make it available. I think you can sort of compare different data sets. So if you're close to a few different points, it will be able to compare this data, etc. So it's something fun just to play around with. We haven't, so I did just show you how do I get my plot object out of R. I welcome anyone to chime in if they have experience with this, but the only way I can think of getting this out of R is that you'll notice that your export options, you can save it as an image, but that will make it static. You can copy it to a clipboard, but that will also make it static. But now instead you have this new option, which is save as a web page. And what it will do is it will write it as an HTML so that you could open it in a web page and have it be interactive there. But it's still then a hard file saved on your computer. So I think that if we end up talking about R Markdown and sort of that sort of final presentation in our last week, then we could talk a little bit about loading objects up into HTML. But that's not something I'm going to dive into too much now, unless people are really dying to know. But that's sort of a quick glance at how you get from these plots that we're making that end up in our plot file to fancy interactive things on a website or a compilation of things in a publication. And like I said, there's a ton to play with as far as different arguments and different GG extensions. I still am learning, oh yeah, all sorts of things, which maybe is the last point that Michael brought up, which was the GG bin point. So this is just a fun new thing that we all learned about right now, or not GG bin, but using scale color bin in ggplot to bin continuous data. So you'll notice, let's see, what example were we using before? I think if we did.
I did MT cars and then did the weight MPG one, but then did color by horsepower.
All right, so we're using what we used pretty much before, but in Stellar, instead of coloring by something, actually we just colored it red before, but maybe typically you would color it by like model or something that is a character that's already discrete in nature. And so R understands that Volvos are one color, that Audis are another color. If you try to color by a continuous variable, which I think you said MPG, we'll see what this looks like first. So then if you did geom.
I did HP for this one. That one will turn out pretty nice.
Yeah. So he colored by horsepower. And then if we just did geom point at this, the default of colors for continuous variables are shades, really. So instead of having a distinct color for every number, because even R recognizes that that's a little bit ridiculous with continuous variables, it will just sort of give you this intuitive shading, and the default is blue. But if you wanted to say, can you categorize these for me? Basically, if you can bin it and make these into factor groupings on my behalf, R, that would be really great. And they have now done this, so like we said, when we want to add in colors, we often start out with scale _ color. And so a few different options, you'll see that scale color bind is one of the first things you'll see, which is convenient. And if we just execute that, it's tough to know that there is a difference, but you can also use these arrows to toggle back and forth between plots. So you'll see in the previous plot, it sort of let you know that these shades, you'll see even within each grouping, there's a shade, and then it sort of ticks off. Generally, this is the number represented by this shade. In this new version, you'll see that these are actually distinct colors that represent different bins of horsepower.
And you can control the number of bins. If you do try like n dot bins equals 4 or 3 or 4, yeah.
Eh,
Um,
let's see.
I know that works for, maybe it's just bins. I know it works for if you do scale color Viridis B, I know that that one allows you to use that.
Okay, so let's see. So here's just color bins, which are sort of a default. We can also use the Viridis mode of color bins, so Viridis bins. But so instead of doing the scale color bin, we can do scale color Viridis, and you'll notice so this is a relatively new thing, and they have, like I showed before, scale color C and D. But if I used the English/Australian spelling, which is where this package developer is from, they have conveniently only added the bin feature to, if you are fortunate enough to spell color with a U. So now we have scale color Viridis binned. And yeah, if I execute that, we'll see it also defaults to these 6 categories, but now they're clearly more distinct. And Michael, did you say that is nbins an argument in here?
Oh, sorry. My bad. It's n.breaks. I'm so sorry about that. That probably works in the other one as well. Instead of bins, it's breaks.
Okay, so 3 breaks, which is maybe technically 4 bins. You'll now see that we have fewer colors, now 3 breaks at the 100 marks. And so you can sort of lump together and create your own factors of continuous variables using this color scheme, which is super cool.
And you can do this for like things like, I believe, alpha, size, kind of any of those types of aesthetics. There are binned versions as well, and you can control all sorts of things about them if you read up more on them. But it's just nice to know they exist because this is super handy. You could go into your actual data and make these bins by hand, but it's really nice to be able to do a quick one like this. And I believe it even lets you do, you can make you can use it for categorical or for like an x-axis as well. So you could take a continuous value on an axis and do a binned scale on the axis, and then do something like bars to make a histogram of sorts. But you can do it, you can combine them in creative ways. So just worth knowing that this exists.
How would you go about changing the default just base color? So in that first example under color bins, it's scale color bins with 3 breaks and the default's blue shades. How would you go about changing it to like green or red or whatever?
I believe there's a palette argument in a lot of these default color ones.
Is it in, I usually, would you use this?
No, there's usually, there's kind of like, there are general scales that allow you to pass different values to them. Like some of them that are called manual allow you to define manually like what colors you want to use in a scale. There are pre-made ones like Viridis that have a color scale baked in. And then there are sort of, you know what I mean? There's like pre-packaged ones, and then there are ones that let you make them yourself. Yeah, you can see.
So kind of like there are, I think, a dozen different ways, and some of them are separate packages that you can then layer on, but are also then built in. So I usually go the route of adding this scale color, choose your, like pick your poison sort of situation onto my graphs. Although if people have other opinions or like go-tos for how they add colors, I mean, I am a color brewer person, except that because I've already binned, that doesn't really make any sense. So maybe that's not the right route. Because I don't know if usually I would do this without having the breaks or the continuous, except this is now a bad example for this. I don't know, Christian, how would you change color in this circumstance, do you think? Because I would normally.
So I have not used the binned before, but it looks like, I was hoping as I was Googling it, I'd be able to arrive at a solution. I was not. Yeah. For actual continuous stuff, I typically use one of the Viridis packages, but you can also use Brewer, like Liza said. And for discrete stuff in particular, I often use scale color manual and then just define the values on my own with things that are pleasing to me to look at. And I use that R colors guide that I shared with you all, I think last week, which I will put on the chat right now.
Yeah. Yeah, I'm actually not gonna have a quick answer for this, Logan, because I clearly have my like go-tos, which are usually in like the Viridis palettes. And then I'm like I said, ggplot is one of those things that for me, at least, there's so much to it that I don't memorize them. It's like beyond my coding literacy to know all the different arguments. And I'll usually consult the Google world of like code books and cookbooks for kind of quick fixes that I feel like are so accessible. I never need to bother to memorize them. I realize we're out of time. There is a homework assignment this week that's just more plotting practice. And so we can go ahead and stop there, or we can hang out and talk about colors and ggplot all day. That's up to you guys. But if you don't want to do that, I will say goodbye unless there's any closing questions.
Please fill out the post-class survey.
Please.